Hi everyone, our team is going to talk about the simulation using Arena in the case of Lego manufacturing. We have 5 team members, Yayun Wang, Jingxuan Zhang, Mingzhu, and Wen Jian, and Wen Yeyuan. This is the outline of today's presentation. We will discuss about the background and problem state first. Afterwards, we will introduce our model, user interface, and result analysis. Finally, we will end with conclusion. Let's begin with the background introduction. Lego is a popular line of construction toys that consists of colorful interlocking plastic bricks and accompanying array of other parts. It is very popular among children because they can use their imagination to construct whatever they like with Lego bricks. In order to produce more types of bricks, Lego has more than 100 colors. Besides, due to the different features of different bricks, Lego has a relatively complex manufacturing process. In this case, it is necessary to reduce the complexity of its production and find the optimal allocation of its resource. Under this situation, we build our model of the production line and simulate it. Now you're understanding the big picture of a project. Let's go into the problem part. We're at the end of November and Christmas is coming. Lego is facing a large seasonal demand. To improve Lego manufacturing efficiency, we simulate Lego's manufacturing process using Arena. We also want to find out the optimal percentages for resource allocation in order to minimize the waiting time. We have 4 main stations on the manufacturing floor. All the raw materials go to the shaping station first and then go into printing station. Afterwards, they might go to quality assurance station and assembly station. We simulate 3 types of products. For type 1 products, they are advanced toys which have structural and functional features, such as robots. This kind of product needs to go through all the 4 stations, from shaping to printing to quality assurance and finally to assembly. For type 2 products, they allow kids to assemble by themselves and they don't need to go through the assembly stage. But if some parts are lost, it will significantly affect the final product set. So type 2 products need not only going through the shaping and printing stages, but also the quality assurance stage. For type 3 products, they are sold as the whole assembled products. Kids don't need to create the features by themselves. Besides the shaping and printing stages, they need to go through assembly stage to complete the final product. We summarize our problem as follows. According to Lego's current situation, all the raw materials first come in a size of 10 boxes, in which 30%, 10%, and 60% belong to product 1, product 2, and product 3 respectively. Arrival rate for these raw materials is in a uniform distribution format from 60 to 120 minutes. Based on the 4 manufacturing steps, we simplify Lego's production line into the following points. First is arrival node. The raw material will come in boxes, and based on the proportion of target products, raw materials will be fitted into different processes. They will probably go through modeling station, painting station, quality assurance station, and assembly station, and then exit the product line. Our main considerations here are the delays or waiting time of different production processes. Since Lego wants to improve the efficiency without investing more money, we would not change the number of machines at every station. At the same time, the production time is fixed at each point. So our goal is to minimize the waiting time by changing resource allocation. This is the general layout of our job shop model. 3 lines of different colors represent 3 different production processes, and the number of circles represents the number of at each station. The process time at each station will be decided based on the production type. In this chart, we'll list the production process of each product type and its original allocation. The numbers in the 4th column indicate the production time at every step for 3 types of products. The objective of our project can be divided into 4 parts. First, we will analyze the waiting time at every station. We want to see if there is a potential to reduce the waiting time. Similarly, we will also analyze the utilization of machines. We want to make sure that machines will not be too idle or too busy. And then, based on the assumption that LEGO does not want to increase the capacity, we mainly focus on how to allocate the raw materials. We change the production of raw materials in every batch so that waiting time at every station can be reduced. Finally, based on analysis of different proportions, we want to propose a better solution to LEGO so that they meet all the demands at Christmas. Now, let's move on to the real simulation and model part. The model is built up in an arena. Toys arrived every 1.5 hours on average, with batch size is 10 boxes. Each box weighs 100 pounds. When different type of products coming in, it is assigned with toy ID, shaping time, printing time, QA time if there's any, and assembly time if there's any. Let's look at how arrival works. Toys arrive 1.5 hours on average, as I mentioned earlier, and entities per arrival is 10, which indicates the batch size is 10. And then, passing through the assigned part, each toy is assigned with different IDs, shaping time, printing time, QA time, assembly time if there's any. And later, when it's going through the shaping time, as you can see on the right part, the shaping time has been passed through the expression and referred later. And later, the second part of the model is going through different type of the machines, shaping first, printing second, and going through quality assurance if it is needed, and later it will go through the assembly if it's needed. And most importantly, the processing time will be adjusted via different toy ID. As I mentioned earlier, every type of the product will have shaping and printing time, but it may have quality assurance time or assembly time. Now, let's look at how the interface looks like. The interface is being implemented through Arena VBA. This is how the interface looks like. Then let's look at how the Arena works. This is our interface, and what you need to do is put in two parameters. One is the percentage of a product 1. For example, let's say 50%. And on the right side, you need to put second parameter, which is the percentage of product 2. Let's say 40%, and hit run. And you can see the simulation runs smoothly for a couple of seconds. And the line is actually showing how many machines are being used in there. And later, when the simulation is completed, we'll actually see this button to ask whether the result has been available or not. And this is how the report will look like. Now let's move on to see what are some results that we have. We totally did 7 simulations with different kinds of production allocation. And here are the results of the waiting time and utilization of machines we've got from the 7 simulation. These are the first 4, and these are the rest of the 3. What are some analysis that we have done? First, we list the average flow time of each simulation and found 3 simulations with the least flow time, which is simulation 1, simulation 5, and simulation 7. Then we pick these 3 simulations and compare the utilization of machines among those simulations. We could see that simulation 1 was the most balanced utilization of machines. So we finally got our optimal product allocation with 60% of product 1, 30% of product 2, and 10% of product 3. Which means when product 1 are the most, product 2 follows, and product C are the least. We could realize the objective of minimizing the waiting time and best balancing the machine use. Here is another discovery. we listed all the utilization of QA machines in the 7 simulations and found that the use rate of the QA machine was very low, which means we don't need such kind of big machine. Here are some suggestions. Based on our simulation result, we summarize this suggestion for improvement. The optimal resource allocation should be product 1 bigger than product 2 bigger than product 3. And we could replace current QA machine with a smaller one to save money and energy. Now come with the conclusion part. We have the objective to simulate LEGO's manufacturing process with Arena and find the best resource allocation to minimize waiting time. With this purpose, we choose our variables, proportions of these products in user interface, trying to find the optimal solution. After running the simulation model and testing different results under different variables, we can find that optimal allocation of the 3 products, product 1 greater than product 2 greater than product 3, and the company should replace the current quality assurance machine with a smaller one. That's all we have. Thank you for your time and attention.